Okay, I'm just going to talk you through question 7 from exercise 9I, which involves finding the area between two curves. So here we can see we've got f of x, which for the bit of the area that we are finding is on top. And then we've got g of x for the bit of enclosed area that we are finding is at the bottom. And the formula that you can use for this, and this formula works actually no matter where this area is, whether it's above or below the axis, it doesn't matter. We can say that the area is the integral between these two limits, so A is the lower intersection point and B is the upper intersection point. So between A and B of the function at the top minus the function at the bottom. And we integrate that with respect to x. So this is the formula that I'm using, and I'm going to go through question 7. So here I've got my x-coordinate, so my x-axis and my y-axis, and I've got two functions. I've got quite a simple function, just y equals 6, and I've got y equals x squared plus 2. And I've got the area that's enclosed is that part. So using this formula, the area that I want is the integral from a to b, and a will be this point, which I need to find. B will be this point, which I need to find. And my top function here, the one that's on the top, is 6, y equals 6, and the one that's on the bottom is x squared plus 2. So before I can really integrate that, I'm going to simplify it and figure out what a and b are. So here I'm just thinking, what is the intersection of these two curves? It will be when x squared plus 2 equals 6. So that's when x squared is 4, so when x is plus or minus 2. So a is negative 2 and b is 2. So this will be the integral from negative 2 to 2 of this, which actually simplifies to be negative x squared plus 4 with respect to x. Now I do the integration, I get minus x cubed over 3 and 4x. I don't need to worry about putting plus c because that will cancel out, but if you do include plus c, well, it will cancel out, so it won't give you the wrong answer. It's not necessary when we're doing definite integration with limits like this. So then what I do with these two limits is I substitute the top value, upper limit, and I take away, substituting the bottom limit. Okay, and when I do that, I don't think I need a calculator for this. I get minus 8/3 and plus 8. Here I get, this will be minus 8. With this minus makes it positive. With this minus it makes it minus again. And here I get minus 8 minus minus 8 is plus 8. So actually they both work out the same once we've included the minuses. So this is 16 minus 16/3, or 48 minus 16/3, which is 23, which is 32/3. So that is the area. And I put something like units squared because it's an area. Okay, that's it.